What if I told you that a piece of technology can mean the difference between finding someone in time and not finding them at all? I'm Mark, Public Solution Engineer at DJI, and today we'll be talking about the drone that genuinely changing how we do our jobs.
Okay, Mark, let's start with you. Walk us through what your day actually looks like. Because I think a lot of people don't fully appreciate the pressure your work or the pressure you're operating under.
Yeah, I think one important clarification first, it's not really about a day in the field. In public safety today, what we're actually talking about is how drone systems are integrated into wider operational workflows across like wildlife protection, emergency response, and disaster coordination. For example, in Maasai Mara in Kenya, drone operations are used to support wildlife monitoring and improve safety for surrounding communities.
Right. So basically, aerial surveillance over protected land. That's how they used to think about in early deployment.
I'll adjust that slightly. It's not surveillance in traditional sense, it's situational awareness and response coordination. Because the objective isn't the observation, it's detecting movement patterns, understanding context, and enabling faster decisions on the ground. In environments like that, the challenge is scale and visibility. You're covering vast open areas where activity can happen at any time, especially at night. So aerial system helps teams continuously monitor and share real-time intelligence across multiple units.
So they used to rely heavily on patrols for that. Ground teams covering sectors on rotation. It was slower, but it was reliable, right?
It was reliable in a sense for our coverage, yes, but not in timing or visibility. That actually where aerial system changed the model. They don't replace ground patrols. They compress the time between detection and response. I'll tell you what, thermal imaging plays a key role here because it allows operators to detect movement in complete darkness or dense vegetation. That's exactly when human or more human in wildlife conflicts happens. Not during the day, but especially at night.
Let me get this right. So they used to think thermal was more of a search and rescue tool, though not really wildlife management.
That's a common assumption for earlier deployments. But now, thermal is primary detection layer, not a secondary tool, especially for movement tracking and early warning system. And it's not used in isolation. Optical zooms provide safe verification for distance. For example, checking tracking colors on elephants without approaching them physically. Because before, they actually use tranquilizer to take down the elephants, and that will be costly for them. So that reduced the risk in the field teams and minimized disturbance to the wildlife.
So basically, they used to just send team closer to confirm things like that. It was slower, but for them, it felt more direct.
Right. But that approach introduces unnecessary exposure, like risks and delays. Now, verification happens remotely first, and only physical teams are deployed when needed. So, Tristan, let me share you about laser rangefinder. So, this laser range measurement also helps teams understand spatial relationship in real time. Let me explain why. How far the movement is from a settlement to boundary. That support preventive action instead of reactive response. And then with the precise GPS marking, those insights are instantly shared with rangers via QR code. So teams and everyone is working in the same operational picture. What you're really seeing here is a shift away from sequential workflows. Observe, report, respond, into a parallel intelligence where detection, verification, and coordination happen simultaneously.
That same thinking definitely applies to search and rescue. Although in practice, they still prefer using helicopter first.
Yes, but I refine that slightly. It's not about default tools, it's about first available intelligence layer. Whether it's wildlife environments, urban emergencies, or disaster response, the goal is consistent. Improve situational awareness early enough to influence outcomes. So let me give you an example. So in a missing person scenario, the core challenge are still time, visibility, and coverage. So traditionally, response teams rely on ground searches or helicopters. Both effective, but limited in scalability and endurance.
So don't get me wrong. Helicopters are still the fastest way to get eyes in the sky though.
Fast deployment, yes, but not always optimal for sustained search coverage. Because once airborne, they're constrained by cost, endurance, and operational noise, especially over large grid searches. That's why drones are increasingly used as a first response aerial layer. Platforms like the Matrice 400 don't replace those assets. Don't get me wrong. They allow responders to deploy within minutes and immediately start building a structured aerial understanding and search the area. Imagine that. Visual, thermal, and spotlight. And you can also put speakers. Teams can run single coordinated missions with multiple data layers.
So you mean they used to split those into separate missions like thermal first, then visual confirmation later?
Exactly. And that sequencing delay is what's been removed. Now, those layers run simultaneously, which reduces time to decision significantly. Thermal imaging enables detection of heat signatures and low visibility environments, even dense terrain or nighttime conditions. It accelerates subjects to the location. And instead of covering an area in hours, aerial search patterns can reduce time or timeline dramatically.
And disaster response is even more chaotic. Infrastructure is gone, communication is limited.
Correct. Yes, but I reframe that slightly. The key issue isn't chaos, it's loss of operational visibility and access at the same time. Like floods, landslide, and structural damage often remove physical entry points entirely. So drones become the fastest way to restore situational awareness without exposing personnel at risk. With omnidirectional sensing and stable flight performance, the platform is designed to operate reliably in complex environments while continuously feeding real-time data back into the command centers. And with the long-range transmission and extended flight time, that awareness scales across entire operational zones, enabling coordination and even when command infrastructure is at a remote area or partially compromised. What we just saw in environment like Maasai Mara is exactly why the next generation platforms like the Matrice 400 are designed the way they are.
If you're working in inspection, public safety, or anywhere in between, subscribe, leave a comment telling us what specific challenge you are trying to resolve. We read them. And if you want to talk about how Matrice 400 helps into your specific operation, contact us at sales@aerosmart.ae. Our solution engineers will be happy to assist you. We do this every day. Thanks for watching. See you in the next one.